Hello guys, welcome to my channel called Science Simplified. Today, I welcome you to our journey into the world of attosecond pulses of light. In this video, we'll explore what attosecond pulses are, how they work, where they're used, and their limitations and the Nobel Laureates associated with this phenomenon. First, let's break it down. An attosecond is an incredibly tiny unit of time, lasting just a billionth of a second. Imagine a blink of an eye, but way faster. Now, imagine light, which usually flows like a river. Attosecond pulses of light are like super quick flashes, lasting only attoseconds. But how do we create these super fast flashes of light? Scientists use super powerful lasers. They shoot incredibly short and intense laser pulses at atoms. These pulses are so quick that they kick out electrons from the atoms, creating attosecond pulses of light. Let's take a closer look at this phenomena. When the laser light enters the gas and affects its atoms, it causes electromagnetic vibrations that distort the electric field holding the electrons around the atomic nucleus. The electrons can then escape from the atoms. However, the light's electrical field vibrates continuously and, when it changes direction, a loose electron may rush back to its atom's nucleus. During the electron's excursion, it collected lots of extra energy from the laser light's electrical field and, to reattach to the nucleus, it must release its excess energy as a pulse of light. These light pulses from the electrons are what create the overtones that appear in the experiments. But how did they calculate these super-fast overtones? To find out the answer, let's take you to an experiment performed in France. Pierre Agostini and his research group in France succeeded in producing and investigating a series of consecutive light pulses, like a train with carriages. They used a special trick, putting the pulse train together with the delayed part of the original laser pulse, to see how the overtones were in phase with each other. This procedure also gave them a measurement for the duration of the pulses in the train, and they could see that each pulse lasted just 250 attoseconds. But the question still remains, how did they isolate a single overtone? To find out the answer, let's take you to an experiment performed in Austria at the same time. Ferenc Krausz and his research group in Austria were working on a technique that could select a single pulse, like a carriage being uncoupled from a train and switched to another track. The pulse they succeeded in isolating lasted 650 attoseconds, and the group used it to track and study a process in which electrons were pulled away from their atoms. These experiments demonstrated that attosecond pulses could be observed and measured, and that they could also be used in new experiments. They let us see how tiny particles, like electrons, move around super fast. It's like using a high-speed camera to capture the dance of these particles around atoms. Now, let's dive into some cool applications. In medicine, attosecond pulses can help us understand chemical reactions in our bodies and even develop new drugs faster. In the world of materials and electronics, they can improve things like solar panels, making them more efficient. But wait, there are limitations. Attosecond pulses can only travel short distances, and they need a lot of energy. So, they're not suitable for all tasks and not sustainable. What does the future hold? Scientists are researching new ways to use attosecond pulses, like in super-fast quantum computers. The Nobel Prize in Physics for the year 2023 was shared by these three scientists. Through their experiments, this year's laureates have created flashes of light that are short enough to take snapshots of electrons' extremely rapid movements. And Laureate discovered a new effect from laser light's interaction with atoms in a gas. Pierre Agostini and Ferenc Krausz demonstrated that this effect can be used to create shorter pulses of light than were previously possible. We salute to their dedication to science. In a nutshell, attosecond pulses of light are super quick flashes that help us see the incredibly fast world of tiny particles. They have applications in medicine, materials, and beyond, but they also have limitations we need to overcome. Thanks for joining us on this attosecond adventure. If you found this video fascinating, don't forget to like and subscribe for more mind-blowing science.